Okay, today we're going to make a foldable dealing with the different triangle centers we're going to learn. So you need to start out with a piece of paper and we need to make it into a square. And the easiest way to do that is to take the upper right corner and fold it over so that it matches up along the left edge. Okay, and so take your time and line it up and crease it. And you're going to have this edge at the bottom left over that we're going to cut off. So grab yourself a pair of scissors. You're going to take that and cut that bottom section that overlaps. And so when you do that, and then when you open it back up, you now have a square. Okay, so after you cut it, I do want you to open it back up, and then I want you to take the other corners and fold them over so that they connect and crease it. So get everything all lined up and make that crease. And then when you open it back up, it should have both of those, I guess, indentations or those creases. So we're making kind of like a fortune teller, if you remember from elementary school, although we're not going to go all the way to the end of making the fortune teller. So open it back up like this, and we're going to take each corner and fold it into the center. So I'm going to grab one corner, fold it in, and crease it, and I'm going to go ahead and leave it shut. And then grab another corner, fold it in, grab another corner, fold it in, and then finally the last one. And so what this is going to do for us is give us a foldable that we can write a title on, and then we can open it up, and then we're going to write some details. Okay? So what I'd like you to do actually is turn this over, and we're going to title this Triangle Centers. Triangle Centers. And you might also put your name on this. That way, if you lose it, you'll be able to find it again. All right, once you get your foldable made, you are also going to take, I gave you this strip of paper with 3 different types of triangles on it. And I want you to label it first, and then we're going to cut them out and tape them in our foldable. The first one on the left here are going to be perpendicular bisectors. So go ahead and write perpendicular bisectors above that. Let me switch to pen. I don't think that's showing up very well. Perpendicular bisectors. We're labeling these so that when we cut them out, we know where to put them. Our next one is going to be angle bisectors. I don't know why I'm getting such a glare on that. Let me try to refocus my camera here and see if that gets a little better. Actually, let me grab another piece of paper and put that in drawing. There we go, that helps a little bit. All right, so we have perpendicular bisectors, angle bisectors, and I want you to write medians above the third one. M-E-D-I-A-N-S, medians. So when we make, what we're going to do now, actually, let's cut these out. So if you would grab your scissors again, and let's go ahead, I'm going to trim them up kind of small so that I can actually get that to fit into my foldable. So if you want to pause this video and cut your squares out, please do that. Okay. All right. We are going to grab your foldable again. Okay, and let's turn it over. Doesn't matter where you start. Pick one of your flaps to start with. And what I'd like you to do is we're going to begin with what's called the circumcenter, and we will learn more about this in a minute. The circumcenter is spelled C-I-R C-U-M-C-E-N-T-E-R, circumcenter, and in parentheses, the circumcenter is formed by the perpendicular bisectors. So perpendicular bisector. Okay, circumcenter. All right, next one, I'm just going to rotate this. The next one is called the in-center. The in-center. And the in-center is formed by the angle bisectors. The angle bisectors. The in-center is formed by angle bisectors. Next one is called the centroid. C-E-N-T-R-O-I-D. The centroid is formed by medians. So in parentheses, I'd like you to write the word medians. And then our fourth and final one is called an orthocenter. O-R-T-H-O-C-E-N-T-E-R. Orthocenter. Orthocenters are formed by altitudes. Okay, so we're going to work on just a couple of these today. So let's go back to circumcenter, and you will need some tape. You'll probably need 3 pieces of tape. So if you need to pause this and get some tape, go ahead and do that. When you open up the circumcenter, circumcenter goes with the perpendicular bisectors. So I want you to take your tape and maybe fold it backwards so that you can tape it down, or if you want to add some more tape to it. We're going to tape this here on the top part of the flap. Okay, so what I did was I went to my perpendicular bisectors, close my parentheses here, and then I opened it up and I taped that down. So let's do the same thing on our other 2 triangles while we're making our shell here. So my in-center goes with my angle bisectors that I labeled earlier. So I'm going to grab my tape and I'm going to tape that one down. Okay, and then my last picture goes with the medians, so the one we wrote medians on. Let's tape that one down too. And I do not have a picture for orthocenter, so we will work on that later on when we get to orthocenter. We'll sketch a little picture. All right, so let's go back to circumcenter. And what I'd like to do is write a few ideas down about this. We learned about perpendicular bisectors already, but let's summarize here on the inside what we have. So our first item that we're going to write down, this particular point in the middle is called the circumcenter. It is the intersection of the perpendicular bisectors. One of the properties is this intersection from the various sides here is it's going to be, this particular segment is going to be the same distance as the segment going to the other vertice and over to C. So I'm going to write equidistant from vertices. Equidistant from the vertices. So what that means over here, that means that segment P over to A is equal to P over to B and P over to C. So I'm going to write that at the top here. PA equals PB equals PC. So if one of them is 5, they're all 5. The distance to each vertex is the same length. And visually, they look like they're about the same length. Okay, one more comment here that I'm going to write here about this particular triangle center. This dot here can land inside the triangle like we see, or it can be outside the triangle, or it can land right on one of the triangle sides. So the second thing I'm going to write is circumcenter. Circumcenter can be inside triangle, outside the triangle, or on the triangle. And if it's inside the triangle, then we have an acute triangle. If this particular circumcenter lands on the outside of the triangle, then we have an obtuse triangle. And if it lands right on the edge or the line or the side of the triangle, it is a right triangle. So that's just kind of an interesting fact about the circumcenter. Okay, so circumcenter Perpendicular bisectors bisect the side, but the distances from the center to each vertex is the same length, not the distance from the center over to the side. Those are not the same length. Okay, so that would be our circumcenter. All right, let's move on to incenter. The incenter is the result of the three angle bisectors. And so my picture is showing here the angles being chopped in half or bisected. All right, so we have a slightly different property that develops on this. So we are going to write, it is not going to be equidistant to the vertices. This time it's equidistant to the sides. So the incenter is equidistant to the sides. The incenter is equidistant to the sides. And in fact, I could come up here and add a congruent mark, and a congruent mark. Okay, and so what that means is segment PY is equal to PZ is equal to PX. So segment or length of PY is equal to PZ is equal to PX. Those lengths, and visually they look equal. So you can kind of go by the visual look of it. Okay, so those are the incenters. This incenter will always be inside the triangle. Always inside triangle. So unlike the circumcenter, it's always going to be on the inside. Okay. I actually am going to go back to our circumcenter and let's mark, we wrote over here to the side what was equal, but let's mark that. Let's mark, let's see, I'm going to go ahead and use a highlighter because we already have 1, 2, and 3 marks. I'm going to mark with a different color. And it kind of shows up for you all. I'm going to mark the distance from the vertex to the edge, and maybe I'll even highlight it. Those are the same lengths on my circumcenter, and that kind of shows up for you, not real well. Maybe I'll do the same thing here on my perpendicular, my angle bisector. Those are my 3 lengths that are the same. Okay, we are going to stop here today because we are going to work on the other two, the median and the medians and altitudes a different day. Okay, so have this foldable with you. This is a good reference, a good quick thing to pull out and reference as you're working.